Hello everyone, my name is Anish. My registration number is AP241100100629. Today I'm going to explain about the crucial role of pre-processing a problem statement. Pre-processing means preparing data before actual search in it. The slide explains that sorting and searching are closely connected. If we sort data first using algorithms like sort and quicksort, it comes make searching much faster and easier. The slide explains the highlight points: efficiency comparison, binary search impact, total time measurement, and data setup specifics. Coming to the first, efficiency comparison. Efficiency comparisons, we compare merge sort and quick sort to see which one is better as pre-processing setup. Coming to the next, binary search impact. Binary search works best only when the data is already sorted. So better sorting, next faster searches, especially when we repeatedly search. Coming to the third, total time measurement. We calculate the total time taken for the both sorting plus searching to check the overall performance. And coming to the last, data setup specifics. Different data setups need different algorithms. We look at memory usage, data size, and speed to choose the best one. And coming to the next slide, for sorting and searching fundamentals. Sorting arranges data in logical order. It improves the data accessibility. Different sorting algorithms have different specific complexities. Searching pinpoint information. Searching retrieves specific information from data. Binary search requires the data to pre-sorted. If data is already sorted, the repeated searches becomes extremely fast. Thank you.
Hello everyone, myself Adithya. My roll number is AP241100100617. Now let's move on to the mud sort. Mud sort is a reliable and efficient sorting algorithm that follows the divide and conquer method. It means it takes a big list of items, break them into the smaller parts, sort the smaller parts, and then put them back together into the correct order. Because it always follows the same structure process, mud sort gives a consistent speed of big O of n log n in the best, average, and worst cases. One big advantage of the mud sort is stability. Means that if two items are equal, their order is kept in the same after the sorting. This is very useful in real life applications. However, mud sort does not need extra memory. It has a create temporary arrays while merging the pieces back together. Even though it uses the more memory, it also helps the algorithm stay reliable. Mud sort is especially good for sorting very large and complex datasets, and it works well when the data is stored under disk rather than its RAM. Because of this, it often uses for external storing tasks. Now let's move on to quicksort. Quicksort is another very popular and faster sorting algorithm. It is also known for its being efficient, which means it does not need much extra memory. The quicksort works it by choosing something called pivot. The- Then it rearranges the list so that the items are smaller than the pivot goes to the one side and items larger than the pivot go to the other side. The simple idea makes quicksort extremely faster and more types of data. On an average, quicksort also has the time complexity of big O of n log n, which makes it one of the fastest sorting algorithms in practice. It also uses very little extra memory, which is much lesser than the much sort requires. But quicksort does not have a drawback. It does not have stable and have a worst complexity. Because of its speed and low memory usage, quicksort is widely used in system libraries and real-time applications where quicksort performance is important. Now my friend will continue.
Hi, my name is Shreyank Gautham and my roll number is AP241100100591. Today I am going to briefly compare linear search and binary search and explain their importance in real-time large-scale databases. Searching is a fundamental operation in computer science used to find a specific element from a collection of data. The two common search strategies are linear search and binary search. First, let us talk about the linear search. In linear search, each element is checked one by one until the required value is found. It works on the unsorted data, which makes it simple and flexible. However, its major drawback is performance. In worst case, it takes off and time, meaning the time increases as the data size grows. For small data sets, this is acceptable, but for large data sets, it becomes very slow. The next is binary search. Binary search requires the data to be sorted beforehand. It works by dividing the data into halves and repeatedly and comparing the middle element with the target. Because of this approach, it has much faster time of complexity, that is O of log of n, Although the sorting takes some initial time, binary search is extremely efficient and especially when multiple searches are required. Now, let us look at some real-time scenario involving large-scale databases. Industries such as banking, telecommunication, and government system handle millions of records every second. In such systems, using a linear search would cause delays and poor performance. Therefore, data is first sorted and indexed, allowing binary search or similar techniques to retrieve the information almost instantly. This pre-processing ensures fast responses, high system reliability, and scalability as data grows. In conclusion, linear search is best for small or unsorted data, while binary search is ideal for large-scale data systems where speed is crucial. Proper pre-processing using sorting combined with binary search plays a crucial role in modern database performance. Thank you. And my friend will continue.
Hello everyone, my name is Adithya. My roll number is AP2411001058. Now I am going to explain about e-commerce platforms. Real-time e-commerce platform really heavily on fast searching and sorting algorithms to deliver a seamless shopping experience. When users browse products, they expect pages to load instantly, items to be organized clearly. Sorting products by pricing, ratings, or popularity helps shoppers find what they want without frustration. This efficient product organization plays a major role in keeping customers engaged. Enhanced search and filtering capabilities also contribute to higher user satisfaction. When users can quickly locate the exact what need, they are more likely to stay on the platform and complete purchases. And inventory changes frequently, the platform must update results instantly without delays. Personalization features such as recommendations and smart filters depend on real-time processing to users are often guided toward the most relevant products based on their preferences. Therefore, a performance optimization is crucial to customer retention. Search engines embedded within these platforms constantly analyze large datasets. Advanced sorting methods ensure that results remain accurate. Real-time updates also help maintain trust in product availability. Overall, dynamic sorting and searching technologies from the backbone of modern e-commerce sites. Now, this is about real-time scenario, file systems and indexing. Sorting and indexing plays a crucial role in real-time file systems, cloud storage, services. Every operating system uses sorting techniques to manage and relate files more efficiently. Which storage becomes easy to maintain, indexing so improves the overall search process inside file systems. Throughout sorted pointers and binary search techniques, indexing can dramatically reduce retrieval time. This means the system does not have to scan every file to find the required one. Minimizing disk access is to scan every file to find. Another major advantage of using efficient sorting algorithms, since operations are relevantly slow, reducing unnecessary reads and writes enhances responsiveness. Faster performance leads to a smoother user experiences. Cloud storage system rely heavily on indexing to handle massive volumes of data. They must be deliver fast access regarding of user location. Sorted index ensure that data retrieval remains quick and relies. Quicksort is often used inside systems for fast in-memory sorting. Meanwhile, mergesort is preferred for large data set for request table and external sum. Thank you. Next, my friend will continue.
Hello everyone, myself Viswam. My registration number is AP2411001006. Today I am going to talk about how sorting and searching algorithms work together to give the best performance in any system that handles data. First, sorting plays a big role in how fast we can search. When data is sorted properly, it becomes much easier and quicker to find what we are looking for. So sorting is like preparing the ground for faster data retrieval. There is no single best sorting algorithm for all situations. The choice depends on type of data, the size of dataset, and what the application is. So understanding the situation helps us pick the right algorithm. When we sort data before searching, especially in cases where many searches happen again and again, it saves a lot of time. This means heavy work is done once and searches become very fast later. Among the sorting algorithms, MedSort is known for being stable and consistent. It works very well for large data set and for external storage. On the other hand, quicksort is fast on average and used often in real-time situations because of its practical efficiency. After sorting, we usually use binary search. Binary search is extremely fast because it cuts the search space into half each time, but it only works when the data is already sorted. So main idea is this: when we choose the right sorting method and combine it with efficient search method like binary search, we can greatly improve the performance of the system. In simple words, sorting prepares the data and searching uses the preparation to give the faster result. Together, they create a powerful synergy for optimal performance. Thank you. Now, my friend will continue.
Hello everyone, my name is Abhishikth and my number is AP2411001068. Today I'm going to explain a simple C code for the sorting algorithms. So this code mainly consists of three algorithms, namely quicksort, merge sort and a binary search algorithm. So at first we take a look at the quicksort. So the quicksort works based on the logic of pivot element, where we compare each number with the pivot element and then place the number either on the left side or the right side of the pivot element. So taking a look at here, at first we create a function which consists of three parameters: int array, int low, int high. So int pivot is equals to array high, and then we create a for loop. Inside this for loop, we create int I is equals to low and j is equals to high and j plus plus. And inside the for loop, we are going to compare of the number with the pivot element, and based on this comparison, if it is higher, we place the number on the right side of the pivot element, and if it is lower, we place the number on the left side of the pivot element. And by taking a look at this, we can see at the end we swap the higher and lower based on the comparison with the pivot element. So this is how we compare the entire pivot elements. Now moving on to merge sort algorithm. Here we can see there is a function named merge which consists of four parameters: int array, int l, int l, int m and int r. So here in the first step we are going to check the left index with the right index and compare them. If the condition is false, where the left is smaller than r, then the subarray has 1 or 0 elements and is considered sorted. And in the second step, we are going to find the middle point. It calculates the middle point of m of the subarray by using the formula int m is equals to l plus r by 2. By this, we are going to get the middle array. And in the third step, we recursively sort subarrays. So they are going to be two subarrays, and we sort them using the merge sort algorithm. It consists of two merge sort algorithms. In first one, there's a merge sort of three parameters array l and m, which sorts the left side of the subarray, and there is another merge sort function which consists of another three parameters array m plus 1 and r, which sorts the right side of the subarray. And in the end, we are going to combine this all three. So we create a temporary array which calculates the size of the two subarrays and creates a two temporary arrays LR from the left halves and the right half of the array respectively. The data is copied into these temporary arrays, then it uses three pointers I, j into 1, and in the end copies any remaining elements from the temporary arrays back into the main array. By this we can say the array is successfully sorted at the end. So now moving on to binary search algorithm. Here we create a function named binary search consisting of three parameters: integer array, integer n and integer key. Inside this there are two integers l and r, where l is equals to 0 and r is equals to n minus 1, where l is the left end of the index and r is the right end of the index. Here we create a while loop to find the mid of the array, where mid is equals to l plus r by 2. Using this we can find the mid of the array, and after that we take the input from the user, and using the for loop we match the each of the index with the given number from the user. Then it is going to return the number, and the number is found at a particular index of the array, and if the number is not present inside the array, then it is going to return array. And from here, moving on to the main block, we are going to take the input from the user int n, and then we enter the size. Inside the main block we are also going to calculate the time taken for the quicksort and merge sort to implement inside the code, and also where the index is found. Executing the same above code in the compiler, the output we are going to get is this, where we enter the size, which is 10, and the quicksort and the merge sort, the time taken to execute both these algorithms is 0.0003 seconds, and the element is found at the index 3 after sorting, and the element is 2777. So this is going to be the output after executing the entire code, which consists of the merge sort, quicksort and the binary search.